Hello, in this video we'll start to look at charge, current and potential difference. Now, what is charge? Okay, charge. Well, charge is measured in coulombs, denoted by the letter C. And the coulomb is defined as the amount of charge that passes in 1 second when the current is 1 amp. So it is the amount of charge that passes in 1 second when the current is 1 amp. So we get from here some equations. So we can get that change in charge is equal to current times change in time, or simply Q equals IT. So charge is equal to current times change in time, or simply charge Q. Q stands for charge. Although Q is letter for charge, it is measured in coulombs C, which can be a bit confusing. Current times time, and you can also from here say that the current is equal to the rate of flow of charge, is change in Q over change in time. So these are things that are about charge, but I still haven't actually said what charge actually is. We know that charge is measured in coulombs, C. We said that it is represented by the letter Q, and we also know the definition of it. Okay, but what is charge? Well, okay, this is quite. But I won't answer it completely, but I'll give you more information. Probably because I'm not exactly sure what it is, what this charge is. Now, what I can say is an electron has charge, and so does a proton. Has charge. The electron charge is negative, and the proton charge is positive. Okay, and negative charge is attracted to positive charge. They will attract each other. So there's a bit more information. I can also say that the charge on one electron is equal to 1.6 times 10 to the minus 19 coulombs. That would be negative. Also, the charge on a proton is also 1.6 times 10 to the minus 19 coulombs, and this is known as the elementary charge. Okay. Now we can also say that there are a lot of electrons in a coulomb. In fact, to find the number of electrons in a coulomb, all you need to do is put the value of 1. So we want a number of. So how many electrons in a coulomb, and that is equal to 1 over 1.6 times 10 to the minus 19. Okay, that's how many electrons there are in a coulomb. Okay, now you have to do that calculation yourself, because I don't have that's a number. I don't have a calculator handy. Number of electrons in a coulomb, 1 over 1.6 times 10 to the minus 19. So we know that a coulomb is a very large, has a lot of electrons in, and we know that charge can be positive and negative, and the charge on an electron is equal opposite to charge on a proton. Okay, let's talk a little now about let's talk a little bit about how charge flows in a metal. Okay, so let's say this is a metal. Okay, and charge in a metal, let's say it's got a little tube of metal there, like a wire, and charge in a metal is a free electron, and there's approximately one free electron per atom. So here might be little free electrons. Okay, and they will travel. So when a potential difference is applied to them, we'll talk about potential differences. These will, on average, they will travel in a certain direction. Okay. Now, what really happens is they will go in a certain direction, and so let's say there is a charge. So let's say they're being attractive towards the positive there. Okay, and they'll travel in a certain direction, and they will bounce off positive ions, and they'll bounce back, they'll hit ions and go the other direction, but on average they will drift. They will drift along. Okay, on average they will drift along. And let's say let's give the average, the formula for this is this drifting. If you like, you have the formula, so that's drift velocity. First of all, drift velocity is given by v. So this is an average velocity that an electron or any charged particle will feel. And the equation is this: you get the current that travels is equal to the number of charge carriers n multiplied by the cross-sectional area A multiplied by the drift velocity, that's the average velocity that they're travelling, multiplied by the charge carrier. So here we have, this is the general formula, I equals NAVQ, for it could be carrying any charge, but specifically if it was if it was in a metal, it would be electrons, so that would be I equals NAVE, where E is equal to 1.6 times 10 to the minus 19 coulombs. So this gives you the total current, and remember N is the number of, if you like, charge carriers per cubic meter. So that's charge carriers per cubic meter. A is the cross-sectional area, V is drift velocity, and Q is the size of the charge. And for a metal, the charge is that because it's in an electron that is travelling. Now, one last thing: if the electrons are travelling in that direction towards positive, by conventional terms, the current is actually flowing in the opposite direction. Because conventionally we say that charge will flow, or sorry, current will flow from positive to negative, because originally they thought that little positive charge is flowing, when in fact the reality is it's the electrons will flow from negative to positive, but we say that the current is going in the other direction.